Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, the GMAT Official Guide 2024. If you do not own this book already, purchase one immediately. You're going to need it. Always make sure that this book is in front of you when we are working together. Today is our lesson number 40. We are on page number 100. On page number 100 you will find 3 problems in the first column, 167, 8 and 9. And that's what we're going to do today. Problem number 167 is already on the blackboard. Problem number 167, if you happen to have the book in front of you, you will see that it is actually a bar graph. But I was too lazy to actually draw the entire bar graph, so I put down the entries on the blackboard. And here are the entries. There are entries, some manufacturing figures for some factory for 11 years from 1990 to year 2000. And these are the entries. In 1990 they show a bar that is little under 200, 175. Then there is a bar that is just a little over 200, 275, 300, so on and so forth. The question is very straightforward. Question is very simple. They're asking us which one is the closest to the median among these 5 answer choices. 250, 280, 310, 325, 340. Go ahead, do it yourself. Pause the video and do it yourself. Well, here we go. As I gave it away a second ago without realizing, unwittingly that is, that there are 11 entries, not that you couldn't count, but there are 11 entries, not 10. 1990 to 2000, there are 11 entries. Since they are looking for the median is going to be the 6th entry. We just have to find the 6th entry. We just take our time, don't rush, take your time. What's the smallest one here? I see 175, that's the smallest one, that's number 1. And we don't have to go through entire 11 of them. As soon as we find the 6th entry, that's the median. Then we have something under 200, that's it, that's number 2. Then we have little over 200, that's 3. Now we have to slow down. Number 4, there is a 250. I was about to mark 275, but there is a 250, that's number 4. And then 275, that's 5. And there is another 275, I believe. No, that's it, 275. Something little over 300, that's number 6. There you go. That's number 6. That's full. Everything else is just to double check. That's 350, 375, 375, 400, 375. Yes. Little over 300. There you go. That's your median. Median is going to be the bar graph that is shown as little over 300. So we just pick one entry that is just a little over 300. Something that is little over 300 is this guy right here. 310. That is the median reading of these 11 entries shown in the bar graph. Next one. We need the rule. We don't have to analyze all 11 of them. As long as you have confidence in your work, as long as you take your time. We know there are 11 entries. We just have to look at the 6th one. That's all. Because we're looking for the median. Number 168 says that we have a symmetric distribution. We have symmetric distribution about the mean. Of a large population. That's a very important bit of information. We are further told that 68% of the observation lie, 68% of the observation lie, not lies. 68% of the observations lie within 1 standard deviation. Here's the question. Question simply is, what percentage of population is going to be below this value, mean plus 1 standard deviation. Standard deviation is what I'm using, symbol D for standard deviation. The question is, what percent of the population is going to lie below this value, mean plus 1 standard deviation. And here are the answer choices: 16, 32, 48, 84, and 92. Again, do it yourself. Pause the video and do it yourself. I'll give you a second to be able to pause the video. Let's see what we have here. The fact that they go out of their way, to tell us that we are dealing with a very large population, and then they go on to tell us that 68%, almost 2/3 of the observations lie within the 1 standard deviation. I hope you were able to realize right then and there that what they have just described is a normal distribution. Normal distribution looks like this. And it is symmetric about the mean. All the clues are there. We have a distribution that is symmetric about the mean. We do have a very large population, and 68% of the observation lie within 1 standard deviation. Well, what else do you want? That's normal distribution. That is the definition of normal distribution. It looks like this. And here is your mean. As you can see, it's symmetric about the mean. If say this is 1 standard deviation, then from here to here, all the values that fall between here to here, this is your mean. So this is going to be mean plus 1 standard deviation, this value. And this value is going to be mean minus standard deviation. And they're telling us that everything that falls within this range, it captures 68% of the population. Which of course we knew that. The question is, what percent of the population is going to be below this value? What percent of the population is going to be below this value? We already know that this area captures 68% of the population. We just have to figure out this part. So let's do that, shall we? So here we go. If from here to here, from a value that is 1 standard deviation less than the mean to the value that is exactly 1 standard deviation above the mean, from this value to this value, if it captures 68% of the population, then it stands to reason that we must have 34% of the population here. We must have 34% of the population here. Now, if you understand that part, now we can very easily figure out this part. This part that we see here, must be, because this is the mean, which means half the observation lie here. And if from here to here is 34%, then what we are seeing here must be 50 minus 34. 16, there you go. So this is 16%, this is 34%, this is 34%. That's the percentage of observation that lie below this value, everything below it. So mean plus standard deviation, you move towards mean, you have captured 34% of the population. You move from mean to 1 standard deviation below the mean, we have captured another 34% of the population, and then another 16%. So essentially 68 plus 16. That ends in a 4 right there. Because obviously it's more than 50%, because it's already up to 60. It has to be more than 68%. It's 84 because it's going to end in a 4. Obviously it's not 92, because 92 will have a very difficult time ending in a 4. Let's do the next one. Number 168. It says for the positive integers a, b, and k, we're going to see three values a, b, and k, and we are told they are all integers, they are all whole numbers, and they are positive. It says that for these three positive integers, if we see a symbol like this, a raised to k, and then a parallel line, and b, this is what they give us. They tell us that if we see this symbol means that a raised to k is a divisor of b. That's the first condition. But here's the second condition. So that's the first condition. That's what this means. But We are further told that a raised to k plus 1, a raised to k plus 1 is not a divisor of b. We are further told that if 2 raised to k and then a parallel line 72, if this is true, then what must be the value of k? What must be the value of k? Let me give you the answer choices. 2, 3, 4, 8, 2, 3, 4, 8, and 18. Okay, I'm not going to explain anymore, because if I were to explain anymore, we'll start solving the problem. I would like you to try it yourself first, pause the video and do it yourself. I'm simply going to read it to you one more time. We are told that for the positive integers a, b and k, when we see this symbol a raised to k and a parallel line and then b, we are told that this symbol means that a raised to k is a divisor of b, but a raised to k plus 1 is not. We are told that this is true. 2 raised to k parallel line 72. This part is true. If this is true, then what must be the value of k? Go ahead, do it yourself. Let's take a look at it, shall we? The most important part here, which I was debating whether or not to tell you in the beginning, if you did not know it, what I'm about to do, if you did not know it, and if that was the reason why you were having trouble solving it, then once I tell you, you can pause the video one more time and give it a second shot. The most important part in this problem is knowing what this word means. Divisor. Divisor simply means factor. Factor. For example, if you were to, let me give you a simple example. For example, if you had a value of 10, and if you write down the prime factors of 10, is 2 times 5, which means 2 is a divisor of 10. In other words, 2 is a factor of 10, and 5 is a divisor of 10. 2 and 5 are divisors of 10. That's what it means. So if that's the reason why you were stuck at this thing, and if you want to give it a second shot, be my guest, pause it again and do it one more time. Okay, let's take a look at it. We are dealing with here a value of 72. So the very first thing we should do is to break this guy up in its prime factors. Let's do it in the top here. We need the room, so I'm going to erase all of this thing. But remember, we are told that a raised to k is a factor of b, but a raised to k plus 1 is not. That's the clue. And the question is, what's the value of k? And these are the possible answers. Let's look at 72 first. Let's break it up. Let's break it up into all its prime factors. Very first prime number is 2, so let's begin with 2. So we're going to have a 3 here, then it becomes 12, that's a 6, that's a 2 again, that's a 18, that's a 2 again, that's a 9, that's a 3 again. There we go. In other words, 72 can be written as 2 raised to 3 times 3 raised to 2. That is, assuming that I have not made a boo-boo. Now all we have to do is take a look at it. Okay, let's begin. Let's start with the value of 2. So, if we start with the value of 2, then 2 raised to 2, we are told, is a factor of 72. That's what this means. If the value of k is 2, which we do not know yet, if the value of k is 2, then 2 raised to 2 has to be the factor of 72, which is true. 4 is a factor of 72. But so is 2 raised to 3. 2 raised to 3, 2 plus 1, k plus 1. We are told that that k plus 1, when a raised to k plus 1 is not. I don't know if I want to rewrite it. A raised to k plus 1, we were told, is not a factor of 72. That's what we were told in the problem. But here, as you can see, 2 raised to 2 plus 1, which is going to be 8, but 8 is still a factor of 72. As we can clearly see here, 8 is a factor of 72. So 2 is not the answer. Let's see what happens. What if k is equal to 3? If k happens to be 3, then k raised to 4, 3 plus 1, k raised to 3 plus 1, which is going to give us 16. Does this meet the condition? Let's first see. So if k happens to be 3, then 2 raised to 3, which is 8. 8 is a factor of 72, but 16 is not. Voila, we found it. We found a value of k where if k happens to be 3, then 2 raised to 3 is a factor of 72, but 2 raised to 4 is not. There we go. Now the question is, what's wrong with the other three answer choices? Well, what is wrong with the other three answer choices is the fact that we can't even get going. From the get-go, 2 raised to 4. If k happens to be 4, can k be 4? The answer is no, because 2 raised to 4 is not a factor of 72. We only have 3 2's. If 2 raised to 4 is not a factor of 72, doesn't even make any sense to ask ourselves, is 2 raised to 4 plus 1 factor of 72? It's a moot point. Similarly, why the bloody hell would we ask ourselves if 2 raised to 8 is a factor of 72 when we just established that 2 raised to 4 is not a factor of 72? And the same thing goes for 18. The answer is 3. The answer is B. That was the end of the show. I'm going to stop right here. That was the end of the first column, and that is also the end of the series. I'm not going to make any more videos. I'm done. I'm not going to make any more videos on the GMAT for the year 2024. We'll meet again, hopefully, in the next series of 2025. Alright? Best of luck to you on the exam. If you need help, if you need some help preparing for the math part, I'm always here. Here's my website address, as you can see there. You can go to my website, send me an email, and we'll see what we can do. Okay? Bye now.